M is this 2 by 2 matrix, and we're asked to show that it's non-singular. In other words, it has an inverse, but to show it, we show that the determinant is non-zero, because to get the inverse, it's 1 over the determinant. Just a reminder, the definition of the determinant for this matrix A, B, C, D, we put lines down there like this to show that its determinant is AD minus BC, and it has many uses, including the inverse, but elsewhere as well. So for us, we're going to get the determinant of M is equal to 1 times 1 minus root 3 times root 3. That's going to be minus 3. So we're going to get 4. Not equal to 0. Make sure you say that. Therefore, M non-singular. Good. The hexagon R, I don't exactly know what it's going to look like, is transformed to the hexagon S by the transformation represented by M. Given that the area of R is 5, find the area of the hexagon S. Now, the determinant, you've got to remember, gives you the scale factor when for the enlargement when you multiply basically the hexagon by this matrix M. So we know the determinant is M, that becomes our scale factor. So it all comes together from there. The area is going to simply be 5 times 4, 20 square units. M represents an enlargement with center 0, 0 and scale factor k, followed by a rotation anti-clockwise through an angle theta about 0, 0. Find the value of k. I'm just going to write down my system of equations first, and then we'll talk about how we can do this really quickly. So remember, it says an enlargement followed by, so the rotation is actually going to be on the left. And this is given the formula book. Rotation by theta is cos theta sine theta minus sine theta cos theta. Quite a nice one to try and memorize if you can. An enlargement scale factor k is k 0, 0, k. And that, remember, is equal to 1 minus root 3, 1. Now, here's how we can do it super quick, and I'll do it like slightly quicker. We're doing a rotation. That will not affect the size of the hexagon or any shape that we apply it to. So the determinant of this is 1. It's actually just cos squared plus sine squared. It's 1. And then the determinant of this one is equal to k squared. But remember, we know that, so we've got 1. That does not affect it. And we've got k squared, and we ultimately get 4, as we know before. And there is a formula that says the determinant of A times B is the determinant of A times the determinant of B, but we can also like argue it logically here. So the rotation does not affect the area. This one does by k squared, and overall it's by 4. So k is just going to equal the square root of 4. It's going to be 2. When we say enlargement, we tend to mean a positive enlargement, but it really clarifies it here. K is greater than 0. So you can write plus or minus 2 and then reject the minus 2 if you want. A slightly longer way to do it would be to actually multiply the matrix out. Actually, I'm not even going to do that. You get k times all of this, and when you then find the determinant of that, you would get k squared, and then in brackets, cos squared plus sine squared, which is 1, and you get the same result. So now we can just bring it together, but with the k involved. So we're going to get 2 cos theta. Basically, we're just going to times everything through by 2. 2 cos theta minus 2 sine theta, 2 sine theta, 2 cos theta. Okay, and from this, we can construct equations. It must be that 2 cos theta is 1, so cos theta is a half. And if I just look at this one here, sine theta is going to be root 3 over 2. If we look at any others, they're equivalent to it. like this equaling this also gives us sine theta as root 3 over 2, and this equals this gives us cos theta as a half again. So let's solve it. Theta is for inverse a half, gives us 60 degrees, and we also get 300. But you might recognize that sine is positive, so we're definitely going to be dealing with the acute angle here. So theta here is then 60 and 120. So we reject these. Theta is 60 degrees. The only other way you could do, they've kind of hinted at it with the determinant. You could do this without the determinant. And I remember I did a question in the past, like forgetting that we could use the determinant. So if you didn't know that it was it was 2 and you had a k here, then you could write down k cos theta equals 1. And the same here, you could write down k sine theta equals root 3. And you could actually divide through by like the bottom one divided by the top one, because then you get tan theta equals root 3. And you would end up solving that. Theta would be 60 or 240. And then you could put each of them back in. Now, if you put 60 back in, it would work. You would get, over here, you get a half and k would equal 2. Sorted. If you put 240 in, you would end up getting minus 2. So you would actually, that's why you would reject it. So it's just a kind of different way to think about it. Finding theta first and then k. Um, you know, it's a solid approach as well. But here we've done it with the determinant. It was a little bit quicker with our other answer. Well done.